Okay, so you want to install your own radon mitigation system. We're going to go over the necessary steps to get you to that final safe level of radon in your house if you're having issues. One thing that I want to hit on is I recommend getting a professional to come out and do it for you. There's a lot of steps that aren't very safe. This is an instructional video on how to do a DIY, do-it-yourself radon mitigation system installation. Okay, so if you're ready to install your own radon mitigation system with the safety precautions in place and the education that you have in your brain, let's get started.
When we're sizing our radon fan, we have to understand and determine two items. The first item is friction loss. In our system, what is friction loss? In our system, the air travels through the piping, and as it goes through the piping, the air gets slowed down as it rubs up against the sides of that pipe. As it goes through turns, it slows down. So the friction loss of the entire system has to be determined to make sure that the fan we select can handle that amount of obstacles. The second item that needs to be figured out is CFM, so cubic feet per minute. Cubic feet per minute is basically airflow. It's the volume of air over time that moves. So cubic feet volume per minute time. There are actually two other important factors, or two more important factors to consider when selecting your fan. So there's the previous two, understanding the amount of friction loss. The second one was determining your airflow. The third one is what type of subgrade material you have below your basement slab. That is also important. So subgrade material below basement slab. So it could either be a porous material, so it could be stone, like crush and run, where there is good airflow through that, or it could be clay. You know, maybe the person who laid the foundation put it on top of clay instead of what they should have done and used a stone. Understanding your material under will help select your fan, because if you have a very thick clay underneath your slab, your fan is going to have to suck a lot harder. If it's porous and air can easily be sucked through the rocks and taken out of your home. The other one is the area of your basement. So a lot of radon fans can be sized off of the square footage and how large your basement is. So there's four total. Four important design criterias.
Our basement is 30 feet by 25 feet, and we want to know the area of our basement slab. So we're going to do 30 feet times 25 feet, which gives us 750 square feet. Here in my hand is a duct calculator. I know this is for medium smooth galvanized duct, but it should suffice for Schedule 40 PVC. I mean, they're both pretty smooth surfaces. The coefficient of friction is probably a little different, but whatever. And so we're going to size it for a 4-inch here, above my thumb here. We're going to size it for a 4-inch pipe, and so I'm lining that arrow up right here. And then we can look at the CFM, and let's go with 100 CFM. And now I'm just randomly choosing this number. What 100 CFM represents is the amount of air that is going to be pulled out from underneath the basement slab. And so, I mean, if you have a smaller basement, you can go with a smaller CFM. Pulling 100 CFM
out from underneath the basement slab, I think that's fine. And we're at about 0.6 inches of friction loss. 100 CFM, 0.6. At 50 CFM, we're about 0.18 or 0.16. And so we're going to use this relationship to determine at 4 inches of round pipe, we're going to use that relationship of 0.6 over 100 feet, because over here it's friction loss per 100 feet. We're going to use this relationship to determine the amount of static pressure from the piping that makes up our system. So we need to figure out how much friction we have, how much friction loss. That'll help us size the radon fan. So what we want to do now is lay out the route our piping is going to take up to our fan and then past the roof. Most states require, I'd probably say all states require, that the radon air that is sucked up from beneath the slab is discharged above the roof. That is so that none of the air has the potential of getting back into the home. So it's discharged above windows, just discharged above soffits that are part of your exterior of your home. So no air can go back in. So we want to go from our French drain that's below the slab out through the exterior wall and then past the roof. So if we route our piping, I'm thinking that the design is going to look something like this. We're going to go from the slab and then we're going to have a 45-degree angle up towards the wall and then go up along the wall and then make a 90-degree angle up outside through the exterior wall. And we're going to make sure that this piece of piping here is sloping back into the house. Because when it rains or when precipitation forms inside of your radon piping, you want it to all drain back towards your French drain, which then drains to the sump pit, so your sump pit can then discharge it outside of your home. So we're going to 90 through the exterior wall, we're going to 90 up towards our fan, and then we're going to come up past our fan, 45-degree angle back up towards the house, and then another 45-degree angle to go up along the house and then to discharge above the roof. Now, what's important is we understand how many joints there are. So here we have 145, another 45, a 90-degree angle, a 90-degree angle, a 45-degree angle, and a 45-degree angle. So we have a total of 1, 2, 3, 4, 5, 6 joints. So we have 6 joints in our system, which is here, 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 and here. The next step is to understand the total amount of length, or the total length of piping in our system and the size. So what we're going to size for is a 4-inch diameter pipe or piece of PVC, and we're going to use schedule 40. And we want to know the total lengths. So we want to know this information here. So let's give these numbers, let's give these pipe lengths some numbers. So let's say 25 feet, and now you can measure the outside of your home. This is probably close to 30 feet. And we're gonna work within like 5 feet here. So let's give this 2 feet. Let's give this 1.5 feet, another 1.5 feet. And then let's give this distance where it goes horizontally from outside the home into the home. Let's give that distance 5 feet. And then this vertical distance, and then this diagonal distance, and then another vertical distance. This distance here is probably about 10 foot ceiling. And this isn't going to go all the way up to the first floor. So this distance here is probably, say, 3 feet, and then this dimension down here is 3 feet, and then this diagonal distance, let's say, is 2 feet, something similar to that. And then we add up all of these lengths to get the total length of our system. Total length. So we have a total length of 43 feet. Now, each joint is estimated to have an equivalent length of 15 feet. So one joint equals 15 feet. Equivalent. I think that's how you spell it. Equivalent length. So now we need to know how much additional feet does each joint put on the system. And then that equals 6 times 15. So now we do 6 times 15, which is 90 feet. So the total amount of piping we have on the system is a total length of 43 plus 90 feet, which is 43 plus 90 feet equals 133 feet. Now, what we also have to include in our system is the amount of piping we have under the slab. So if we go back to the footprint of the basement, we have piping that runs all along the perimeter of the basement, something similar to this. Goes along the exterior walls, and then it goes to the sump pit that's in the corner. And then over in this corner here, I'm going to have the drop for the radon system go through the floor. And basically what you want to do is you want to take the longest distance, or go to the furthest point, which is across. So this will be the furthest point here. And you want to use this length because what you're looking for is the farthest run of piping, and this is like the same path of travel here. So instead of taking all the length of piping, so this 30, 25, 25, the air is gonna travel from this point, and it's gonna go down and then out of the hole where the radon pipe goes through the floor. If we have enough power or force to pull air from this point, from this side, we'll have enough power or force to pull air from this direction as well. And so the total amount of added length is 25 plus 30 is 55. So we take the 30 here, 30 plus 25 equals 55 feet added in. And then we take our 133 feet from the previous setup that we had, and we add the above 55 feet, and we get a total of 188 feet. And then from the duct calculator, we know that for every 100 feet, there is 0.6 inches of friction loss. So for every 100 feet, there's 0.6 inches of friction loss. And we want to know how much friction loss there is at a total of 188 feet. And since it's a linear relationship, we're able to cross multiply. Inches of water column. And then we want to find what x equals. So we're able to cross multiply. And so we get 100x equals 188 times 0.6. And we get 100x equals 112.8, and then we divide both sides by 100 to get x by itself. And we get, the 100 goes away on that side. I should be able to do this. 1.128. So we can round that up to 1.15 inches of water column. So this is basically what we have, the total amount of friction loss on our system. And so we need to select a fan that can handle this amount of static pressure. Static pressure.